Hello, people of the internet. I have some more Presonus stuff coming up. So, this time I have a little bit different sort of video for you. The last 2 or 3 videos that I've done on these Presonus units is something that can you use them in a Linux environment, and this video is going to be operating system independent. And why that is that this unit is a broken one. I bought this for next to nothing. I paid 15 euros for this and I knew that it was broken. This video will have a couple of goals. Number one, I have to analyze the faulty component, which is this power supply board, and if I can analyze what the problem is, then I'll try to repair it. That's the second goal. And the third goal is not to kill myself doing this, because fiddling around with these kind of boards is kind of dangerous, because the thing is that you put AC power here. Now in the net I could find several topics on various websites. All of them were asking that I have a faulty power supply board from a Firestudio project. How do I fix it? There are a lot of these questions, but I could find no answers. So this type of a board is something which is called a switch mode power supply. So this is an SMPS power supply board. Since this is fairly simple, I was able to browse the net a little bit, especially watching some YouTube videos which were discussing, you know, what the different sections of this board are and what they do and why things are like what they are. And based on that information, I pretty much understand what is going around this board. It's a double-sided board. Now, the basic reason why these tend to fail, I think, is because of these electrolytic capacitors. Here is one, here's another one, here's 3 more, and then there's another one here. And these things, as people working with electronics know, these things will, over time, they will fail. The other thing is that what I've noticed is that I have a couple of these other units, and they tend to run really warm inside these enclosures, and this will create heat. Everything inside here will become rather warm. Different kinds of components don't like to be working in too warm of an environment. This is the power management chip, and you can even see that some pieces have been blown out from the top of this. The model that is in this board is called TL3844. It is the same chip as UC3844. This is one of the components that needs to be changed. The other one, which seems healthy here, it's quite close to that, is the FET, the field effect transistor, which is actually, because this is a switch mode power supply, so you know, this is basically the workhorse. This FAT, this FET does the switching. So that needs to be replaced, and usually there is a small resistor here. Resistor number, if I read it from the board, it says R13. This resistor is also blown up. In fact, it was nearly impossible for me to read what it was. I actually took my Digimax D8 and looked up the the code for this component there, because this section of the board, which is a little bit different from this, but this section of the board is identical. But the R13 is 1R0, which means 1 ohm. So these are the 3 components that I will be changing, and the transistor, it's a 3N60L. And also I'm going to change all the 6 capacitors that I mentioned. So then I might be on the safe side to actually plug this in and start analyzing what the problem in this board is, or whether there is anything else wrong. I can visually see no other defects in here, but I still have to test the board, I mean, pretty thoroughly. The next thing what I need to do is desolder the capacitors and all these components and solder in new ones. Hi folks. Compared to the footage that you have just seen, it's actually 3 years later. I ended up putting this unit and this project aside for over 2.5 years, and just this fall, now it's fall 2024, I came back to this project. Long story short, finally I got it working, and a big thanks because of this is that I watched other YouTube videos which were explaining the the ingredients and the functioning of these SMPS power supply boards. And based on that, I kind of knew what I wanted to do. So the first attempt that I had in repairing this failed. And as I probably already said, I tried to change 3 components. It was the processor, the FET, and also the little resistor. I changed those, and then I also changed the capacitors, the electrolytical capacitors. I did that. But on top of that, actually, I think that was the first. I can't really remember anymore. But I think I changed these caps and these 3 components. Couldn't make it work. I don't know why. I wasn't on the level back then to understand really what was going on. But then I was making some measurements with my multimeter, and because I'm a rookie, I mistakenly connected 2 metal kind of places together that I should not have, and these 3 components blew up again in my face. And so that was a little bit discouraging, and then I put it away for 2.5 years. Then I came back, tried to fix it another time. This time I also had changed once again the 3 components here, but also these AC safety capacitors, these yellow ones. I had changed also those, and this blue safety component. Tried to do it again, and it blew up again. But this time 2 of these, because there's a full bridge rectifier in this board, and it's these 4 diodes basically here. And I noticed that the 2 middle ones were broken, and so I changed those. And then I wanted to make a series of measurements that I would see that everything at least seems to work the way it should be, and give me readings what everything should be. I had forgotten that I also used my Digimax D8 unit. It also has a power supply board which is very similar to this. Hold on. This is the power supply board from the D8. Nearly all of the components are also identical. Nearly all of them. This is a little bit different, but all the major components are exactly the same as this one. So I wanted to make the series of measurements with a multimeter, and I used that for this. I measured what I can get from here and then compare it to this one, so I could be sure that things were not screwed up in here in any way. And I did that, and I got this working. First I tried it with the without connecting the output voltages at all, so the rest of the unit here didn't get any electricity. I was just wanting to see if this is gonna blow up. It didn't. So once I was sure that this works, then I connected the output voltages from the board to the rest of the unit and figured out that it works. I have tested it a little bit to see that all the channels work, all the faders work and all that, and it is able to do firewire transaction with an iMac. Right, so it looks like this inside. The power supply board is here. It's under this plastic tag here. That can be removed by removing these 2 screws here. Then we have 4 screws here, here, and then these two long bolts that we have here. Next we have to remove the 2 power output cords from here. They go to the main unit here. One is in here, and the other one is just next to that. So pull those off, and then you have to get rid of the AC socket. That's the last thing. You should just be able to pull it off like that as well. So now we can just slide this off here. So now to the detailed part of how to fix this, or how I fixed it. Basically the only thing I have to do is to make some measurements, and based on some measurements I will then decide whether I need to change some components or not. And then I make final measurements, and that's the whole process. I came up with a laundry list of different kinds of measurements that you might use as a reference for your project. And then I have a list of components and markings on the components that can be found on this board. I think I have to go through a little bit about the basic functionality of the board. I mean, just the very basics. This board has basically two sides. It has the line voltage side, which is in here basically, and then you have the low voltage side, which is the other side of this thing. And the bridge between these two is the transformer right here. And everything on that side of the transformer is like the low voltage, and everything basically on this side is high voltage. In goes the line voltage here. It's from 100 to 230 volts, and that goes in here. And then you have this this yellow things, and then you got the inductor here. This is on the middle. This is sort of the RF filtering circuitry on this board, which means simply that no kind of unwanted noise is coming in from the mains, or if this board creates unwanted noise, we don't pump it to the line. So this is kind of filtering all that out. So in comes the signal. It goes here, the RF filtering here, but it's AC 220 in my case what is here. Then it goes through this full bridge rectifier. After this it's going to be DC power, and then that DC stuff is stored temporarily into this big capacitor here. And this big capacitor here, the transformer will transform the 350 DC into let's say 48 volts, 15 volts, 5 volts, whatever this needs. But it's once again going to be AC. That's because of what the transformer does. That's kind of what electronically happens. If DC goes in, you know, AC comes out, but in a lower voltages. So that's why we have these other diodes here, because they are kind of rectifying the DC once again, the AC once again, which is coming from the transformer. And then there are some smoothing capacitors here. Then they would be this one. And after those, you know, you get the output voltages on these two connectors, and they go to the main board of the unit. Then the switching circuitry, which is here, it's the FET Q1, and then it's the chip here, and also, well, the one of the resistors here, and plus some other things. The switching circuitry over here is the mechanism which is feeding power to the transformer and then finally to the unit. However, the need for power is not constant. It varies a little bit depending what the unit is doing. That's why we need a feedback circuit here. And the feedback circuitry, well, through this optocoupler here, it's electronically isolated. The feedback is on the low voltage side, and all this stuff is on the high voltage side. So the optocoupler here is kind of isolating the two. But this feedback circuitry is telling the switching circuitry here how much current is needed, and it kind of guides the switching circuitry to do enough switching so that we get enough power to the whole unit. Then there are also other circuits going in. It's not really this simple. There are other things going on in here. For example, there are snubber circuits and all that sort of stuff. So if you decide to do this yourself, there is one thing that is a little bit hard here, and that is to deal with these surface mounted components, these SMC components. I had to change 3. The chip, the FET, and the resistor here. And it is not trivial to solder them off and on. So this is the hardest part of what you need to do. Look it up from YouTube, and there are tutorial videos on how to deal with SMC components. You need a good soldering iron. You need also flux, especially for this stuff. And then you need a multimeter in order to do the measurements. Let's go to the measurements. I have a laundry list of them here, and we'll go through them together, so you know what you should expect from if you try to make measurements here. So you have some reference values now coming up. I'm going to put into continuity mode. We need to make sure that electricity is passing through. If you hear a beep, it is. The first thing you gotta figure out, you have to measure, is the fuse on the main box. It comes out from there. It's like this type of fuse that we have here. Put it in here. There's a shoe for that. And then you can measure the continuity that it isn't blown. If you get a beep, it's good. It's good. Fine. Now I can put this back to the place that it goes. It goes there only one way. Okay. like so. Now we can forget about this box. The first thing, and also probably the last thing you should do, is also a continuity test. What you're going to do is, this is the AC input in here, you can see that, and the middle one is not really used, but the left and right ones are. You should not get a beep if you do this. If you connect the leads to the left and right, you should not get a beep. If you have a beep now, it means that something is shorted out here, and you need to figure out which component it is. It's probably not these yellow ones, because if they fail open. But for example, the electrolytic capacitors, if they fail closed. And if you want to measure this, I need to put it on resistance here, like so. So what kind of resistance should we get if I measure from these poles? It should be very high. What we get here is, at this time, it's about 15 mega ohms, as you can see, or like 15 mega ohms. This is really good. The next thing you're going to do is you need to go to continuity mode again, which is this one. Take the FET here. It's component Q1 in the middle of it. It's here. You put one lead, you put it on back here, like so, and then on the other side there are two legs, and the middle one is cut. If you touch the middle one, you get a beep, because because these are connected. But you should not get a beep if you touch the left leg or the right leg. Neither one of these legs should give you a beep. If you get a beep, then this component is faulty. I have not found a way to test this chip here. I mean, I just don't know how to measure that. You probably also need to power this board up, and then you're dealing with AC power, and no thanks. But you can measure the kind of shunt resistor, which is number R13 here. The resistance and what we should get here out of this, if we measure it, is 1 ohm. I go here and we get, how much do we get? Okay, 1 ohm. Exactly what it should be. Then you have the main capacitor, and then I have to switch this to capacitance. And then we're going to measure how that is. We have to do it from the other side. Okay, minus is this and plus is that. We should get something like 47 or close to that. It's going to do the measurement, and we get like, well, 41. Close enough. Close enough, because the rated value is 47 microfarads. So this is okay. Then we go to the bridge rectifier diodes, which are these things over here. Then I have to put this to a diode mode. Just a moment. There we are. And when we measure this, we should get something like 0.5 or 0.6, 0.4. This was 0.6 something, which is fine. I go through all of them. This is 0.59, 0.6, 0. What's the last one? 0.602. Ah, fine. They are fine. They give you a consistent reading, and you know it's fine. Then we have the after transformer diodes. Okay, they are number D7, 3, 10, and 11. They are after the transformer, and they live right here. Let's measure those next, starting from D7. The line is on the right, so the black lead goes on right. So what do we get? We get like 0.45. Oh, fine. And then we have D3. We get 0.51 something. Yeah, fine. Then we get D10, and I can already see that that needs to be the other way around, like this. What do we get from here? 0.44, something like that. Oops. Okay, 0.44, that's fine. And then we have the final one, which is D11. And we get like 0.27. This is fine. I got the same reading from the D8 board as well, so you know. Then we got the backside diodes. Okay, there is D6, D9, and D13. They are on the other side here. Starting with D6, which is this one. Oh, that's going to be this way, I guess. We get 0.512, so that's good. Then D9, what do we get here? We get like 0.3 basically. That's fine. And D13, let's see if this is the correct way. Oh, it's not. Diodes are, if you're dealing with diodes, the polarity is important because a diode is like a one-way switch. The electricity can go one way but not the other way. So that's what diode does. And we get like 0.3-ish once again. That's completely fine. And while we are measuring the diodes, I have one more, which is D1. And that is located here on the output side. And let's see what we get from that. We should get something like 0.7. We get roughly 0.7, so this is fine. And then there are the backside resistors. I could have done it together with the diodes, but okay, let's do it. So then I have to go to resistance here, like so. Okay, our resistors are 4, 5, and 6. They are on series, so and I think they are about 33 kilos each, so we should get something like close to 100 kilo ohms, and we get about 99, which is almost perfect. What else do we have here? And then we have R2 and R3. R2 measures like 33 kilo ohms, and R3 measures 33 kilo ohms. They're the same. Right. So then I have next the blue X-rated capacitor. It's, I think, rated at 3.3 nanofarads, so it's about 3.8, 3.9 nanofarads, and that's okay. What next? We have the black NTC resistor here on the input side, this component right over here. What we should get is close to 16 ohms here. What we have there is, you know, close to 16 ohms, which is what it should be, because this is actually a 16 ohm resistor. Inductor. Okay, that's next on the list. It's the kind of the transformer looking thing with the windings between the two yellow capacitors here. The winding has two sides. One is for the line side, this one, and the lower one, that's for the neutral side, or whichever one is line and which neutral, because it's AC, so it's switching. So here we just need to find continuity. And so this is the other side, and if it beeps, it's okay. Electricity is getting through, and also the other side of it, fine, it's working. So we went with that. Then we have the white capacitor, which is this one here. It's C1, and I get a resistance. It's probably an AC component as well. I actually don't know quite know what this is. I haven't changed this, but I have measured resistance, and if I measure it from the legs here, I get some kind of a reading. Let's see what we got, like 33 kilo ohms. Yeah, that's pretty much what I get. And then we have the yellow safety capacitors here. As they are AC capacitors, so the multimeter is not going to be able to do a capacitance test here, but instead what I've done is see what the resistance is, and we start with this corner one here, which is C3. We get like a little bit over 100 kilo ohms, and it's growing. That's what I get every time. Then there are C4 and C6. C4 is, let's next try the C4, which is this one here. Let's see what kind of resistance we get here. Seems to be like 8 mega ohms. And C6, which is this one, we get once again like 8 mega ohms, something like that. Fine. They seem to be working, but based on this I just make the conclusion that they are working. Then we can go and do the electrolytical capacitors. Let's start with the big one, the C2. That's the big one. It's supposed to be 47 microfarads, and minus will be on the left if I measure here. We should get something close to 47. Let's see what we got. Okay, and we got about 41 and some change. That's fine. This is 47. Then there is another electrolytical one in here, and that's rated 100 microfarads, and minus side is now on the left, so it's these two. Okay, let's see what we got. We got 101, and we got almost exactly 100 microfarads, so that's okay. And in the same manner you can also go through all the other three. I'm not going to do that here. The ratings are over there, and you can see also which one is the minus side. You can do that yourself. Then we see the transformer, the actual transformer here, and I've done a continuity test here. I measured it like this. There are five legs, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So there are 10 legs here, and it's like this. And I'll put it to continuity, and it's supposed to be so that 1 and 2 give you a beep, but 1 and nothing else gives you a beep, which it doesn't. And then 3 and 4 are together, yes, that gives you a beep. And then 3 plus anything else should not give you a beep, and it doesn't. And then the third measurement you're going to do is put something on 5, and that should be connected to all of the 5 ones here. But if this continuity test is okay, then I think the transformer seems to be working. Then the next item is U2, which is the optocoupler. And if I measure continuity among any of the legs here, not cross in any way, there should not be continuity, because this is supposed to isolate this side from that side. So, but what you can do is you can measure the resistance on the pairs of legs. Start with the left pair here, and that's, let's see what we have about 6.8, 6.9 kilo ohms, and on the right side we have 4.1 and then something kilo ohms. So this is the reading I get, and it seems to work fine. This is basically all the measurements I've done, and you can use this as a reference. Then I made some measurements on the surface mounted capacitors here. I could get a reading out of some of them, but then there was a group of caps that I could not get it. By this I mean these caps here mainly. They are probably so close to each other, it's messing up the measurement, and the multimeter can't pick up the capacitance of those components. I'm going to go through, all the components that I have in here. And I made a spreadsheet file of these values and components I have here, and I'm going to put it on the screen so you can look for yourself. So perhaps as a final assessment, I got this unit working, and these Presonus recording interfaces are really excellent units. I mean, these are really good. And in fact, I think that the industry that is making these sort of digital recording interfaces, 2008 or something, but they already figured out how to make these units. So if you look at the kind of electrical properties of these units, they are pretty much the same on the stuff you have today. Maybe things like these are better, but the recording properties of these remain virtually the same than they used to be in 2008. Based on the stuff that I could find on the internet, the common point of failure on these power supply boards seem to be just these 3 components that I've mentioned multiple times: the FET, the chip, and the 1 resistor. In my case, I had to change those, but there was also something else wrong in here, because I couldn't make this thing work, and the problem was somewhere on the AC side. So if I divide this on two here, it was on the left side here. Probably one of the yellow AC capacitors were failed. I don't know, because I changed all of them, and so I also changed the diodes. But finally I could make it to run. There's a bag of components here which I changed. Probably all the electrolytical capacitors, I really didn't need to change those. So if you're on a budget, so you know, perhaps measure first and then change, because if they're okay, there's no reason basically to change them. But if your Presonus Firestudio unit or Digimax D8 unit has failed, probably it has failed because of these power supply boards. And if you want to fix it yourself, I do hope that maybe this video will give you some guidelines of how to do that. Finally, I'm going to put this in and switch this on and put a microphone here so that you can actually see that this thing works. Well, I shot some footage on testing and verifying that the unit works, but here I have a kind of a snapshot taken out of the footage where I'm testing with a microphone that this is working. I got the unit working pretty much like it should work, but there's one problem, and it is the one that you see here. You should not be able to see these green LEDs on the bottom row here. This should be blank, and I traced it down a little bit, and it is because of the power supply. Apparently it seems that the actual transformer in the power supply board is a little bit faulty. That's a noisy component which is actually creating this one LED worth of noise here. So in this condition you can't actually use this unit for recording. The good news is that I kind of figured out that it is the power supply board which is producing the noise that you can hear in all channels here. The bad news is that I think it is the transformer. That I think it is a custom-made part for Presonus. So, kind of to end the video, this is what ended up happening. I actually have 3 of these units. The first one I bought was such that the unit was good, but the power supply was bad. Then there was another unit for sale. I bought it for next to nothing once again, and that turned out to be that the power supply was good, but the unit was bad. Then I bought a third one, which was a good unit with a good power supply. The lower 2 ones, these are good, perfectly good units and working units. And now I have a bad unit, something wrong with the actual board of the unit. And then there's the power supply that I almost got fixed. Well, as a final comment, it is possible to fix the power supply on these Firestudio units, but my bad luck was that the transformer turned out to be bad as well in the power supply.